Picture this: the universe, a vast, sprawling cosmic tapestry woven with threads of galaxies, stars, and mysteries that defy imagination. It's a place where everything seems to be drifting apart, pushed by the relentless expansion of space itself. Galaxies stretch into filament-like structures, separated by enormous voids, bubbles of near-nothingness that make the cosmos feel like a cosmic foam. But amidst this grand dance of expansion, something shocking is happening right now. Our galaxy, the Milky Way, isn't just drifting through this cosmic web. It's colliding with something massive, something so colossal, so mind-boggling, that it's sending ripples through the very fabric of our existence. This isn't science fiction. This is real, and it's happening as you read these words. Buckle up, because what's unfolding in the depths of space will leave you speechless. Let's set the stage. The universe is expanding. Every galaxy, every star, every speck of dust is moving away from everything else, like dots on an inflating balloon. This expansion, discovered nearly a century ago, is driven by a mysterious force we call dark energy, a force so strange we barely understand it. But here's where things get wild. Not everything is moving apart. Gravity, that invisible hand that binds the cosmos, has other plans. On smaller scales, gravity is king. It's why you don't float off into space right now. It's why planets orbit stars, and stars orbit the supermassive black hole at the Milky Way's core, a monster with the mass of 4 million suns. Gravity pulls things together, and when objects are close enough, with enough mass, it can overpower the universe's expansion. That's why galaxies clump into clusters, clusters into superclusters, and why some galaxies are on a collision course. Yes, collisions. In the cosmic arena, galaxies don't just glide peacefully. They smash, merge, and reshape each other in cataclysmic events that span billions of years. You've probably heard about the Andromeda Galaxy, our closest major neighbor, hurtling toward the Milky Way at a blistering 110 kilometers per second. In about 4 billion years, these two galactic giants will collide, merging into a single, glorious mess of stars, gas, and dust. But that's a story for the distant future. What's happening right now is far more urgent, far more mysterious. Scientists have uncovered evidence that the Milky Way is currently entangled in a collision, not with Andromeda, but with something else, something massive, something hidden, something that's sending shockwaves through our galaxy and rewriting everything we thought we knew about our place in the universe. Let's dive into the heart of this cosmic drama. The Milky Way, our home, is a barred spiral galaxy, a glittering disk of 100 billion stars stretching 100,000 light-years across. It's a bustling metropolis of stellar neighborhoods, gas clouds, and dark matter, a shadowy substance that outweighs all the stars combined. For decades, astronomers believed our galaxy was a relatively stable island, orbiting within the local group, a small collection of galaxies, including Andromeda and a few dozen smaller dwarfs. But recent discoveries have shattered that illusion. The Milky Way isn't just sitting pretty, it's caught in a gravitational tug-of-war with a ghostly giant, a diffuse, sprawling galaxy called Antlia 2. Antlia 2 is the cosmic phantom at the center of this story. Discovered in 2018 by the Gaia spacecraft, this elusive galaxy is unlike anything we've seen before. It's massive, potentially a tenth the size of the Milky Way, but it's so spread out, so faint, that it's been hiding in plain sight. Imagine a galaxy the size of a city, but with the density of a fog. Its stars are scattered across a vast expanse, making it nearly invisible against the backdrop of the Milky Way's own stars and dust. This ghostly giant lurks behind our galactic disk in a region astronomers call the zone of avoidance, a swath of space obscured by the Milky Way's gas and dust, where light from distant objects struggles to reach us. For years, Antlia 2 was undetectable, a cosmic shadow slipping through our telescopes. But Gaia, with its unparalleled precision, mapped the motions of billions of stars and revealed this hidden titan. Here's where things get jaw-dropping. Antlia 2 isn't just sitting there, it's colliding with the Milky Way right now. Scientists have found ripples in our galaxy's structure, like waves on a pond after a stone's been thrown. These ripples, detected in the motions of stars and gas, are the smoking gun of a cosmic impact. The Milky Way's disk is warped, its edges distorted, and its outer regions are vibrating with the aftershocks of this encounter. These aren't subtle hints. They're galactic scars, evidence of a collision that's been unfolding for hundreds of millions of years. Antlia 2, with its diffuse structure, is being torn apart by the Milky Way's gravity. Its stars and gas merging into our galaxy in a slow-motion catastrophe. This isn't a head-on crash like the one we'll have with Andromeda. It's a grazing blow, a cosmic sideswipe that's reshaping both galaxies in ways we're only beginning to understand. But why does this matter? Why should you care about a collision that's been happening for eons? In a universe so vast, it makes our planet feel like a speck of dust. Because this discovery changes everything. It's not just about Antlia 2, it's about what this collision reveals about the universe's hidden forces, the invisible currents that steer galaxies through the cosmic ocean. The Milky Way isn't an isolated island, it's part of a larger story, one where gravity, dark matter, and cosmic expansion are locked in an eternal dance. And there's more. This collision with Antlia 2 is just the tip of the iceberg. Beyond our galaxy, something even more massive is pulling us, something so immense it defies comprehension. Enter the Great Attractor, a cosmic enigma that's been haunting astronomers for decades. Located 150 to 250 million light-years away, the Great Attractor is a region of space so dense, so gravitationally powerful, that it's drawing in thousands of galaxies, including our own. Its mass is estimated at 1,000 trillion suns, enough to make the Milky Way look like a pebble in a mountain range. For years, scientists couldn't see it clearly, because like Antlia 2, it lies in the zone of avoidance, hidden behind the Milky Way's veil of dust. But advances in X-ray and infrared telescopes have pierced this veil, revealing a dense cluster of galaxies in the region. Yet here's the kicker. The mass we've detected doesn't add up. The galaxies we see aren't enough to explain the Great Attractor's pull. Something else is out there, something massive, something we can't yet fully grasp. This brings us to an even deeper mystery. The Shapley supercluster, located 650 million light-years away. This behemoth is one of the densest concentrations of galaxies in the known universe, with a mass of 10,000 trillion suns. It's a cosmic metropolis, packed with thousands of galaxies stretching across hundreds of millions of light-years. Everything within a billion light-years is being pulled toward it, including the Milky Way and the entire local group. The Shapley supercluster is so massive that it's warping the fabric of space-time itself, creating a gravitational well that tugs at the very structure of the cosmos. Scientists now believe the Great Attractor is just a stepping stone, a smaller concentration of mass caught in the Shapley supercluster's irresistible grip. But here's where the plot thickens. The Milky Way's motion toward these cosmic giants isn't just about being pulled. There's something else at play, something pushing us from the opposite direction. This is the dipole repeller, a region of space that's the polar opposite of the Shapley supercluster. While the supercluster is a dense jungle of galaxies, the dipole repeller is a void, a vast, empty bubble 100 million light-years across, with barely any galaxies to speak of. It's not repelling us with some exotic force. Instead, it's the absence of mass that's creating the illusion of a push. In a universe where gravity pulls everything toward regions of high mass, a void like the dipole repeller has no pull of its own. The galaxies around it are drawn toward denser regions like water flowing away from an empty basin. This creates the sensation that the void is pushing us, when really it's the pull of everything else that's driving our motion. This push and pull dynamic is reshaping our understanding of the universe. The Milky Way is caught in a cosmic current, tugged by the Shapley supercluster and the Great Attractor, and nudged by the emptiness of the dipole repeller. But there's a twist. The collision with Antlia 2 is adding a new layer of complexity. As our galaxy absorbs this diffuse intruder, its structure is changing. Stars from Antlia 2 are mingling with our own, altering the Milky Way's gravitational field. This could subtly affect our trajectory through the cosmic web, like a ship adjusting its course after hitting a wave. Scientists are racing to model these effects, using supercomputers to simulate how the collision is reshaping our galaxy and its place in the larger universe. Let's zoom out for a moment and consider the bigger picture. The universe is a place of contrasts, filaments of galaxies glowing with starlight, separated by voids so empty they feel like cosmic deserts. The Milky Way, Antlia 2, the Great Attractor, the Shapley supercluster, and the dipole repeller are all part of this grand tapestry. But what makes this story so gripping is how little we truly know. The universe is vast beyond comprehension, and our telescopes can only see so far. The zone of avoidance obscures key regions of the sky, and our theories about dark matter and dark energy are still riddled with questions. Every discovery, like the collision with Antlia 2 or the push of the dipole repeller, is a piece of a puzzle we're only beginning to assemble. Now let's get emotional. Imagine you're standing on a hilltop, staring at the night sky. Those pinpricks of light aren't just stars, they're entire galaxies, each with billions of worlds, stories, and possibilities. The Milky Way, your home, is part of this cosmic drama, colliding with a ghostly giant, pulled by unseen forces, and pushed by the emptiness of a void. It's humbling, isn't it? To know that we're not just passengers on a quiet planet, but voyagers in a galaxy caught in a celestial storm. This collision with Antlia 2, this dance with the Great Attractor and the Shapley supercluster, it's a reminder of how small we are, yet how connected we are to the universe's grand narrative. Every star in the sky, every ripple in the Milky Way, is part of a story that's been unfolding for 13.8 billion years. But the story doesn't end here. The collision with Antlia 2 is just one chapter. As the Milky Way absorbs this ghostly galaxy, it's growing, evolving, preparing for its next great encounter with Andromeda. And all the while, the Shapley supercluster looms in the distance, a gravitational titan pulling us toward an uncertain future. Will we one day merge with the galaxies of the Great Attractor? Will the dipole repellers push alter our cosmic path? These are questions that spark wonder, that drive scientists to peer deeper into the cosmos, and that remind us why we explore. The universe isn't just a place, it's a mystery, a challenge, and a call to adventure. Let's talk about the science behind this for a moment. The discovery of Antlia 2 was a triumph of modern astronomy. The Gaia spacecraft, launched by the European Space Agency, is a marvel of precision, mapping the positions and motions of over 1 billion stars with unprecedented accuracy. By analyzing subtle shifts in stellar positions, astronomers detected the gravitational influence of Antlia 2, a galaxy so faint it emits only a fraction of the light of its neighbors. The ripples in the Milky Way's disk were found by studying the velocities of stars in the galactic halo, a diffuse cloud of stars surrounding the galaxy. These stars are moving in ways that can't be explained by the Milky Way's normal rotation, pointing to a recent collision. Meanwhile, the Great Attractor and Shapley supercluster were mapped using X-ray telescopes like Chandra and infrared observatories like WISE, which can peer through the Milky Way's dust to reveal hidden galaxies. But the dipole repeller, that's a different beast. Discovered in 2017, it was identified by mapping the peculiar motions of galaxies, motions that deviate from the universe's overall expansion. By creating a 3D map of galaxy flows, scientists found a region where galaxies are moving away from a common point, as if repelled by an invisible force. This void, combined with the pull of the Shapley supercluster, explains about 50% of the Milky Way's motion through space. The other 50%, that's still a mystery, a reminder that the universe is full of secrets waiting to be uncovered. This collision with Antlia 2 isn't just a scientific curiosity, it's a wake-up call. For too long, we've thought of the Milky Way as a static, unchanging home. But it's not. It's a living, breathing galaxy shaped by collisions, mergers, and the relentless pull of gravity. Antlia 2 is just one of many satellites that have crashed into our galaxy over billions of years. The Sagittarius dwarf, another small galaxy, is also being torn apart by the Milky Way, its stars forming a stream that wraps around our galaxy like a cosmic ribbon. These collisions are the Milky Way's lifeblood, fueling bursts of star formation and reshaping its structure. Without them, our galaxy wouldn't be the vibrant spiral we know today. But there's a darker side to this story. The collision with Antlia 2 is a reminder of our galaxy's fragility. As it merges with this diffuse giant, the Milky Way is losing some of its own stars, flung into intergalactic space by gravitational slingshots. The ripples in our galaxy's disk could destabilize stellar orbits, potentially sending some stars careening toward the supermassive black hole at the center. And while the collision itself won't directly affect Earth, stars are too far apart for planets to collide, it's a stark reminder that the universe is a chaotic place, where even galaxies aren't safe from upheaval. Let's take a moment to marvel at the scale of this. The Milky Way is moving through space at 600 kilometers per second, fast enough to cross the Earth in a heartbeat. Antlia 2, despite its ghostly nature, spans a region larger than the Large Magellanic Cloud, one of our galaxy's brightest satellites. The Great Attractor, with its 1,000 trillion suns, is pulling us across a distance that light takes 250 million years to travel. And the Shapley supercluster, with its 10,000 trillion suns, is a gravitational juggernaut influencing galaxies a billion light-years away. These numbers are staggering, almost impossible to grasp, yet they're real, measured by telescopes, supercomputers, and the tireless work of astronomers who refuse to let the universe's mysteries go unsolved. Now let's get personal. Why does this cosmic collision tug at our hearts? Because it's a story of connection. The stars of Antlia 2, once part of a distant galaxy, are becoming part of the Milky Way. In a way, they're becoming part of us. The atoms in your body, forged in the hearts of ancient stars, were once part of other galaxies, other cosmic collisions. Every time we look at the night sky, we're seeing echoes of these ancient mergers, these violent dances that shaped the universe we call home. The collision with Antlia 2 is a reminder that we're not separate from the cosmos. We're woven into its fabric, a tiny but vital thread in its infinite story. But the mystery doesn't end with Antlia 2. The Great Attractor and Shapley Supercluster raise questions we can't yet answer. What's the true nature of the mass pulling us? Is it just galaxies, or is dark matter playing a bigger role than we think? Dark matter, that invisible scaffold of the universe, outweighs normal matter 5 to 1. It's the glue that holds galaxies together, the hidden force that amplifies the pull of the Shapley supercluster. Could there be unseen structures, dark matter halos, or even more exotic phenomena driving our galaxy's motion? And what about the dipole repeller? Is it truly just a void, or could there be unknown forces at work? Forces that challenge our understanding of gravity itself? These questions are why astronomy is so thrilling. Every discovery, every ripple in the Milky Way is a clue to the universe's deepest secrets. The collision with Antlia 2, the pull of the Great Attractor, the push of the dipole repeller, they're not just abstract concepts. They're invitations to wonder, to explore, to push the boundaries of what we believe is possible. Scientists are already planning the next generation of telescopes, like the Vera C. Rubin Observatory and the Square Kilometre Array, which will map the cosmos with unprecedented detail. These tools could reveal new galaxies behind the zone of avoidance, confirm the dipole repeller's existence, or even uncover entirely new phenomena, perhaps a hint of the elusive dark energy that drives the universe's expansion. Let's imagine the future for a moment. Picture a time when humanity has mapped every galaxy in our cosmic neighborhood, when we've pierced the zone of avoidance and seen the Great Attractor in all its glory. Imagine simulations that recreate the collision with Antlia 2 in vivid detail, showing how its stars were scattered across the Milky Way. Picture a day when we understand the Shapley supercluster's true mass, or when we've confirmed whether the dipole repeller is a void or something stranger. That future isn't far off. With every passing year, our technology improves, our data grows, and our curiosity burns brighter. The universe is calling, and we're answering. But for now, let's return to the present. The Milky Way is colliding with Antlia 2, a ghostly galaxy that's changing our cosmic home. We're being pulled by the Great Attractor and the Shapley supercluster, and pushed by the emptiness of the dipole repeller. These forces, gravity, expansion, and the absence of mass, are shaping our galaxy's journey through the cosmos. It's a journey that's been unfolding for billions of years, and it's far from over. The ripples in the Milky Way's disk, the scattered stars of Antlia 2, the distant glow of the Shapley supercluster, they're all part of a story that's as thrilling as it is humbling. So the next time you look at the night sky, think about this. You're not just seeing stars. You're seeing a galaxy in motion, a universe in flux, a cosmic collision that's unfolding right now. The Milky Way is colliding with something massive, and that collision is just one piece of a puzzle that spans billions of light years. It's a reminder that the universe is alive, dynamic, and full of surprises, and we, tiny as we are part of it. Voyagers on a galactic ship, sailing through a sea of stars toward a future we can only imagine. This isn't the end of the story. It's just the beginning. The universe is vast and its mysteries are endless. But with every discovery, we come a little closer to understanding our place in it. The collision with Antlia 2, the pull of the Shapley supercluster, the push of the dipole repeller. They're not just scientific facts, they're a call to dream, to explore, to embrace the wonder of the cosmos. So keep looking up, keep asking questions, and keep chasing the stars.